Hi everyone, welcome to TGIF. My name is Vishnu Agarwal and I'll be your host for today. So the world of generative AI is powered by large language models. However, at the same time, we can see small language models are also emerging. To talk about small language model, I'm joined by Arvind Raman for a short conversation. Hi Vishnu. Hi Arvind. Thank you for joining us today. It's our pleasure to host you.
Pleasure is equally mine. Thank you, Vishnu.
Okay, so Arvind, we have heard so much about small language models, narrow language models. Can you help us understand it and give us an overview about it?
Surely. A small language model is a lightweight model that exhibits characteristics similar to a large language model.
Okay.
Let's take a step backwards. Over the last 15 months, we've heard a lot about large language models. However, there is a need for a custom model that generates a greater degree of accuracy as compared to a general model, and at the same time utilizes a lesser training data set and a lesser training duration. That's where a small language model comes in place. Let's look into the three key differentiators of a small language model. The first is in terms of number of parameters. A large language model generally is trained on, I would say, 80 to 100 billion parameters, or in some cases even trillions of parameters, whereas a small language model is trained generally between 1 to 3 billion parameters, which means that it needs a lesser computational resource, lesser memory, and can be deployed quickly. The second aspect is in terms of training time. A small language model can be trained in a couple of days to maximum maybe a few weeks, whereas a large language model requires a couple of months to get trained. And similarly, from a training data set, a large language model requires billions of words in terms of training, whereas a small language model uses a synthetic data set, which is approximately about 1/10 the size of a large language model.
I see. This is great. So you mentioned about lightweight models. Can you help us understand little bit more about it in terms of its computational resources or deployments, some of its key use cases?
Surely. See, talking of computational requirements, a large language model generally requires a few thousands of TPUs, whereas a small language model can be deployed on a low-end CPU with multiple nodes or even a single TPU. Similarly, in terms of the deployment, a small language model can be deployed on a mobile phone or an IoT device or an edge device, whereas a large language model, purely because of its size, has to be compulsorily deployed on the cloud. Now, talking about use cases, while we've seen multiple organizations build industry-specific applications, the broad use cases can be classified in terms of text generation, in terms of entity recognition, and of course sentiment detection.
I see.
What we will do is, let's walk through a demo wherein I leverage the small language model of Microsoft, that is Phi 2, and build some specific solutions around it.
Okay, let's get started.
Yes.
As you see out here, I have an existing deployment of Phi which I will leverage in this case. For this specific demonstration, we are going to ask it a couple of questions across various domains and check for the responses. In the first case, I'm asking a specific question on astronomy in terms of what is the Fermi paradox. As we see, a Fermi paradox is the phenomena where scientists discover the evidence of high energy particles. Let's go ahead and ask it a question from a different domain wherein we check for the implications of AI in healthcare. As we see, we have asked it diverse questions, and despite being trained on a very small data set, the tool is able to effectively give us responses. Thank you.
Fab demo, Arvind.
Thank you, Vishnu.
So what you just saw was how SLM can help solve specific business scenarios. Be it conversation at the edge or training a language model with your own data with limited compute. I hope this was informative. Thank you for watching and bye for now.